Dear participants at the 2021 Annual Conference of the Ghana Institution of Engineering, it gives me great pleasure to join you for this August event. Let me also express my thanks to the organizing team for extending an invitation to me to share some perspectives with you on the theme Engineering Education, Innovations, and Sustainable Development. My name is Mark Adom-Asamoah, Provost, College of Engineering, GhIE University. To address this topic, Engineering Education, Innovation, Sustainable Development, I propose to tackle this in a reverse order. By this, I will first want to reflect on the concept of sustainable and sustainable development goals, SDGs, after which we will explore the connection between engineering, the engineering profession, and the SDGs. I would like to shed some light on the role that engineering innovations are already playing in the progress towards the SDGs. Having made the close connection between SDGs and engineering profession, I would then like us to turn our attention to the education and training of engineers, without whom the SDGs will be a fanciful wish list. I would like to look at this in terms of numbers and also in terms of their caliber and quality. I will finally share some concluding thoughts on the theme. The concept of sustainability has been explored in the past few decades by various organizations and authors. These include Club of Rome, the United Nations, and many more. In fact, the Club of Rome published that landmark report called The Limits to Growth in 1972, almost 50 years ago, which among others called attention to the unsustainable rate at which the world's resources were being depleted. Closely linked to sustainability is the concept of sustainable development. Sustainable development is often expressed in terms of social equity, environmental protection, and economic viability. Sustainability is defined as development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. That is by the World Commission on Environment and Development in 1987. A brief look at the Sustainable Development Goals. In September 2015, world leaders at the UN General Assembly adopted the 2030 Agenda for Sustainable Development, and along with it, the 17 Sustainable Development Goals and 169 targets. The 17 goals are supposed to guide the global development agenda until 2030 and capture various aspects of human needs, while taking into account the need to avoid overexploitation of the world's resources and take action on climate change. The 17 SDGs are often organized around three important pillars of sustainability, which are economic growth, social inclusion, and environmental protection. Economic growth. None of the SDGs can be achieved without the intervention of engineers and the engineering profession. Economic growth targets, as represented by goals 1, 2, 3, 8, and 9, draw heavily on engineering. Some of the goals, for example, goal 8 and 9, appear more obviously linked to engineering than others. But indeed, engineering and engineers stand at the heart of all the goals. For an instance, in eliminating poverty, which is goal 1, and providing human needs, engineers work to provide shelter, water supply, sanitation facilities, and other amenities that guarantee basic human dignity. Feeding the world and eliminating hunger requires engineers to transform traditional farming practices and provide machinery. We see agricultural and civil engineers working together to build irrigation systems and also work towards various technologies and processes that reduce post-harvest losses. Environmental protection. The goals related to environmental protection also obviously require engineering interventions, even those that seem somewhat far removed from engineering, such as goals 14 and 15, rely on engineering techniques and tools to enable marine biologists and conservationists to do their work. Social inclusion. From building of schools to providing ICT solutions for stronger institutions to making cities more resilient, safe, and sustainable, the intervention of engineers are required at all levels. The SDGs and engineering innovation. It is not in doubt that engineering innovations are already making a huge contribution towards the attainment of the SDGs in Ghana and in other countries around the world. In this section, I would like to look at a few case studies that help in solving and in achieving some of the SDGs. So one such technology, which is an innovation, is 3D printing technologies. This has been used in the building of homes, rapid prototyping, in building of biological organs, etc. This has been found to be particularly useful in addressing the goal number 9, which is industry, innovation, and infrastructure, and goal number 11, which is sustainable cities and communities. I would like to demonstrate this by showing a short video.
It may look like toothpaste, but this 3D printing technology is spitting out a 1,900 square foot house. The concrete foundation, interior and exterior walls, and utility conduits. This is the final product.
We're trying to build houses in half the time for half the price.
New York-based SQ4D printed the model home in about 2 days with barely 3 workers, and it's cheap.
Our profits will be higher, and we will be able to.
So in addition to that, engineering and climate smart agriculture, solar powered irrigation systems, for instance, designed and installed by engineers, are making a big difference in the lives of many farmers across Ghana and Africa. This is a major contribution towards increasing farm yields and helping the fight against hunger. In fact, this also contributes to other goals such as climate action and decent work and economic growth. Engineers worked hard during the height of the COVID pandemic, and contributions were made in terms of the construction of various equipment. We also had the construction of the Ghana Infectious Disease Center in record time. And on the right, we have a ventilator that was developed by KNUST. These, among other interventions, are all engineering innovations that are helping with engineering and good health. The transition towards greener, cleaner, and more affordable sources of energy, such as solar energy, has been driven by engineers across the world. Thanks to engineers, Ghana is gradually but surely taking advantage of renewable energy and energy-efficient technologies. Big data is playing a transformational role in governance across the world. Ghana's recent elections saw the registration of about 17 million people in record time with different fields of data for each registrant. Again, a combination of ICT and big data techniques are improving government revenue mobilization efforts and improving transparency of processes. These help to make strong advances towards Goal 16 of the SDGs, which seeks to foster peace, justice, and strong institutions. Given the centrality of engineers and engineering innovation towards the attainment of the SDGs, what should the role of engineering education be? We need to look at it in terms of the quantity, because there is shortage of engineers, and we also need to look at it in terms of the quality. Engineering education must therefore aim to produce engineering in both quantity and quality. Engineers are needed in their numbers and also of the right caliber to drive the march towards the SDGs and beyond. In the year 2019 to 2020 academic year, the total enrollment of engineering students in Ghana's tertiary institutions was approximately, public tertiary institutions was approximately 25,000. And this excludes the numbers from the private universities. This comprised 6 traditional public universities and 10 technical universities. So you have KN University, University of Ghana, UMAT, UDS, and the rest. These are students enrolled from HND, BSc, BTech, MTech, MSc, MPhil, PhD. And with this, if we make an addition of 15% for private universities, that will mean that every year we will be graduating about 7,500 engineers for a population of over 30 million. I would like to share perspectives from other parts of the world. Engineering education has always been linked with the level of economic growth and development. So the top 10 countries in terms of annual number of engineering graduates has been shared here. The Russian Federation produces 454,436 per annum. United States, 237,826 per annum, all through to Vietnam, which is number 10 at 100,390. Ghana's engineering graduate production rate of about 7,500 pales into insignificance when compared to some leading countries around the world. Of particular interest is that of Vietnam, which, although having a little over 3 times Ghana's population, produces more than 15 times the number of engineers that Ghana produces annually. The particular focus by Vietnam on engineering education has already yielded great benefits for the country, as the availability of engineering graduates has served as a magnet for many multinational companies and global outsourcing businesses. It is also known that in the 1980s, when the US decided to focus on economic competitiveness, one of the competitive advantages that they found with the Japanese system was the sheer number of engineers that they were graduating each year. Therefore, in order to drive the development of Ghana, a greater emphasis on engineering education is needed to sharply increase the supply of engineers to the system. In particular, if Vietnam, which has a population of about 100 million, produces about 100,000 engineering graduates each year, then Ghana, with a population of about 30 million, should be producing about 30,000 engineering graduates each year. Closely linked to the earlier point on increasing the supply of engineers is the point on quality. There is no benefit in increasing supply of engineering graduates who are not fit for purpose. In order to improve the quality of engineering graduates, there is, of course, the need to pay attention to some of the perennial issues such as staff strength, infrastructure, laboratory, and workshop equipment. In addition to this, a fundamental rethinking of engineering education is also needed. There is a need to shift from teacher-centered and knowledge-based learning to a more student-centered and problem-based one. Such approaches are more likely to bring our creativity and innovation, which are ever more critical for today's engineering graduates. Again, the developmental context of engineering education must be inculcated into the students. These can be within the curriculum itself, as through extracurricular activities. For an instance, students should be able to connect what they are studying with the national development ambitions and also to global development agenda, such as the SDGs. Young minds can be creative and extremely innovative when challenged in the right way. Engineering educational instructions must therefore institute measures to create an ecosystem that encourages creative thinking and technopreneurship with the end game of successfully advancing towards the marketplace. Engineering education should pay attention to and encourage transdisciplinary projects in which students from different disciplines come together to solve problems. For example, you can put mechanical engineering students, civil engineering students, chemical engineering students, and even students from the Department of Planning together to help with what needs to be done. Additional emphasis must be placed on creative and critical thinking and the development of soft skills. The role of industry and industry players in the training of engineering graduates remains important and needs to be deepened and expanded. Fresh university graduates always need post-graduation training from industry partners. Engineering training also requires intention and industry experience for students. This greatly bridges the gap between fundamental engineering principles and the practice as pertains in industry. A closer engagement between industry and academia is needed to redirect learning, particularly student projects, towards actual and concrete industry challenges and for greater societal benefit. Skills gap analysis is a highly beneficial process for engineering schools and colleges and helps to advance quality education. Continuous exposure to industry for faculty members of engineering institutions holds great benefit as it enriches both industry and faculty members and greatly broadens perspectives of faculty members. This trickles down to the quality of teaching and learning. Engineering institutions are encouraged to continue investing in this. Improving quality. Engineering educational institutions must patronize female enrollment and the employment of female staff to improve male to female enrollment ratios. Although these ratios have been improving in recent years, some particular programs seem to lag behind. For example, at the College of Engineering, whilst biomedical engineering has a female student proportion of about 40%, mechanical engineering has only 6%. Civil, chemical engineering, and petrochemical engineering are all doing about 25% female ratio. Quality engineering education is one that provides opportunities for both male and female students and takes advantage of their unique endowments to enrich the teaching and learning process. The role of ICT in improving engineering education has been brought to the fore by the COVID pandemic. Increased investment is needed to expand ICT infrastructure and maximize the use of facilities that have already been deployed. Opportunities for continuous and lifelong learning must be explored jointly with industry, engineering colleges, schools, and professional bodies such as the GhIE. KNUST is grateful to GhIE for support in the running of its professional master's program. Postgraduate programs that blend technical engineering knowledge with management, economics, and policy studies must be expanded. In conclusion, ladies and gentlemen, I would like to reiterate the highlights of this presentation. The SDGs must provide a snapshot of the key and urgent global development challenges that need to be addressed. Engineers have a critical role to play towards the attainment of the SDGs. Given the key role of engineers and the role that must be played in the attainment of the SDGs, Ghana and other African countries must sharply increase the number of engineering graduates that are produced each year. Measures need to be taken to improve quality of engineering education to make it more responsive to the needs of the time. Industry is an important stakeholder in that engineering education produces the desired outcomes. With these few thoughts, I would like to thank you very much for your kind attention.